In order to receive aircraft certification in inclement conditions such as snow, the FAA requires that the aircraft be tested in conditions more severe than any pilot will realistically encounter. To certify the S76C++ in falling and blowing snow, Sikorsky brought its test aircraft to northern Michigan in early January of this year. Previous testing indicated that the most severe snow condition for the barrier filter was the fluffy snow that occurs in temperatures below 20 degrees Fahrenheit. The S76C++ uses a barrier filter to protect its engines against damage caused by sand and dust. Ingestion of sand and dust leads to expensive engine repair bills. This design was chosen in order to make the S76C++ the most economical aircraft in its class to operate.
The weather report indicated that Marquette could expect a heavy snowstorm. We arrived at just after sunrise to prepare for the day's testing. By 9 a.m., there were several inches of snow on the runway with quarter-mile visibility. The conditions were all we had hoped for.
Marquette, Sawyer International Airport. Automated weather observation 1528 Zulu. Weather wind 010 at 12. Visibility 1 quarter. Snow. Ceiling 400. Overcast. Temperature -8 Celsius.
The first phase of the testing involves an evaluation of ground operations in heavy snow. I taxied around the runway, constantly stirring up fresh snow to simulate worst-case conditions. The next phase of testing is the most rigorous. It requires that the pilot hover in ground effect and keep the aircraft moving to maximize the recirculating snow cloud. This is also the most hazardous phase of the testing, since this testing is conducted in near whiteout conditions. Visibility at times would drop to several feet, and the only way I could maintain situational awareness was to look through the chin window and try to pick up the runway lights. The final phase of the testing requires extended operations in level flight. I flew the aircraft up and down the runway in a figure-8 pattern. In this phase, we actually saw the pressure differential on the filter decrease over time as the snow cleared itself from the filter.
The aircraft was modified to install a borescope looking into each engine inlet so the conditions inside the inlets could be monitored real-time during the testing. What we observed was that the snow would slowly build up in the filter during the whiteout conditions, but would then dissipate during normal visibility hover and during the level portions of the testing. This is a time-lapse video of one of the filters, and you can see how the snow on the filter comes and goes. By all indications, the snow is sublimating at any time we weren't in whiteout conditions. This is similar to the way dry ice simply disappears at room temperature. After the flight, we removed the filter. You can see the potting soil that we had thrown into the inlet before beginning the test to simulate the worst-case condition of a snow encounter with a dirty filter. At no time during the testing did the in-cockpit barrier filter monitor panel lights ever climb into the warning zone.
By the end of the day, the team had spent 3 hours cycling between ground operations, level flight, and ground effect hovering in conditions of 1/4 mile or less visibility. This far exceeded the FAA's requirement of 1 hour 25 minutes in these conditions. For the most critical hover condition, they spent more than double the amount of time required for certification. This testing demonstrated the S76C++ engines can be operated safely in even the heaviest snow conditions. Sikorsky is very pleased with the performance of the S76C++ and the level of protection that these filters provide to its engines.